Does your teen dread geometry proofs? Do they just hate them as you get into geometry? And we are moving away from algebra and some of the basic courses of mathematics, and now we're moving into higher math. And we are getting to the point where we're having to do proofs. You'll see proof kind of concepts in Algebra 2 and Trig and on above. So, but if your study sessions or your homework sessions, the test, are ending in frustration and maybe tears, how can we help you as a parent to guide your student through this? So I'm going to walk you through just a 3-step thing about how you, not so much the student, but how you walk them through the process. Now, if you want to go deeper into proofs, we have a couple of videos that are linked in the show notes below about how to do proofs, how to help your student to even master proofs. But we're not going to be there today. We're kind of going to give you a 3-step framework for the parent or the teacher or the coach or whatever you want to call yourself. Now, what I want to do is also relate the fact that all of us, are always doing proofs. We're always reasoning through things, and we don't usually think of them as a proof. But I'll give you an example of that here in just a minute. But in these 3 steps, think about how often you might do this during the day. Number 1 is identify the goal. What's the goal? What are we trying to prove? Or what are we trying to reason out? Or what are we trying to solve? In this case, it's okay to say, what are we trying to prove? Be focused on the finish line. You ever lost your keys, right? And what we're doing is we're trying to hunt where the keys are, and you're trying to be logical and reason through, where was I last? Where did I last see them? And you're going through a proof mechanism, but the goal is to find the keys. Once you find the keys, you're not still searching, right? So that's what we want to think about. What's the goal? When we do things in real life, like trying to find our keys, it's clear. It should always be clear. So if your student is sitting here struggling and they're I don't know how to do this, I don't know what to do, then start there. What are you trying to prove? And don't let them just say, hey, right here in the book. Get them to say it. Get them to tell you what they're trying to prove. And the reason is because when they are forced to speak it, or maybe draw it out or write it for you, they oftentimes have the answer and it's right there at them. And the point is not for us as parents or teachers or coaches to be doing the work here, but it's to draw the answers out of them. I might not even know how to solve the problem, but I can draw the answer out of them. So identify the goal. When they're first doing this and they're asking a question, just say, what's the goal here? What are we trying to prove? And they get you to step 1. Step 2 is, okay, maybe they're beyond that. Maybe they know the answer to what they're trying to prove, but they can't get further, or they're stuck somewhere. So what we want to do is say something about breaking down what we know. Again, if we have lost our keys, what do? We logically start saying, okay, where was the last time I saw them? What was I doing? We are breaking down what we know. We've set the goal, now we're breaking down what we know. So you want to write down the given information. Now this is important for the student to do, not you, but for the student to write down, what do we know? Here's the goal. Written down, trying to find the keys. What do we know? So you write down the things that you know for certain. And these are in geometry are called givens. They're statements of givens. This is where in the cheat sheet or the PDF download that we have that will help you kind of reason through this. But so we always start with something we know. We're trying to find the keys. We know what the keys look like. We know where we were last. We have some things we know. We don't know where they are, so we don't have all the answers. But we have some clues we are absolutely certain of. So this is what we're trying to do. In a geometry problem, they'll say, find the angle. Find the angle A. And they'll say, and the angle B is 60 degrees and angle D is 20 degrees. So these are things you know. So it's important, even though it's written down in the book, or the test to write them down again. Here's what we are given, here's what we know. Because proofs are very much a written process. And when you start writing it, as goofy as it may sound, it helps your brain think more clearly. It's kind of like that hand to eye contact just starts working. So break down what you know. So if I'm the parent, if I'm the coach, the teacher, identify the goal. What are you trying to do? If they can do that, they're still frustrated. Okay, what do you know? Tell me what you know. Now, sometimes they know that. Now, that should all be given in the book, and that should be really simple because what to solve for and what is given is usually laid out really, really clear, but we skip over that. So this is why you're trying to get them to do this. Part of this is also you're trying to get them to just slow down and realize they do know some things. Have you ever been looking for something in a panic, right? Like your keys, and you just have to you have to get over the panic, the hurry, and reason through where it is, because running around crazy looking just everywhere is not getting you. You almost have to stop and say, okay, what do I know? I'm missing my keys. That's the goal. I'm looking for the keys. I know where I was last. And then you start looking more methodically. So that's step number 3. So you've got them there. They know what the goal is. They have some reasonable background information. Now help them connect the dots. So you just want to ask them, hey, connect the dots with what you know to what you're trying to get. What's the next step? And the hint is the next step always starts with what you know. When you're trying to find your keys, you go to the last place you remember they are. That's something I know. All right, so the same thing is here, step by step, using any information that you have. So here's the given. And step 1 of a proof is almost one of the givens. Almost always it's one of the givens. So they give you some information, and that's step 1. The last place I saw the keys were in the kitchen. That's step 1. Now, what else do you know? So now what they're going to be doing is they're going to be thinking of definitions or theorems. This is where it all comes into the words of geometry. But these are just other things we know. Definitions, theorems, properties. These things are usually in the chapter. They're just covered, or they're things that they've done a lot of times. So this is kind of like Lego bricks, right? If you're putting something together with Legos, and you just connect one brick at a time. You don't build the whole thing shown in the Lego box. You just have to do one part at a time. And that's what you're doing with the proofs. Fortunately, most proofs are not to the Lego level. So these are the 3 steps. And what you want to do is just calmly try to get your student to walk through these steps. So again, what are you trying to prove? What do you know? And logically, what's the next step? And sometimes you have to ask that over. Okay, they get a next step. Okay, well, that's good. Now, what can that next step bring you? What else do you know? How do you do that? So let me kind of give you an example of this. I've been giving you the lost keys example, but let's go to another one that we do all the time and we don't think about as a proof. But this is how proofs work. Sometimes they're so silly, simple, and obvious that you're like, what's the point? And the point is because sometimes they're not silly and obvious. So let's take this. I need gas for my car, right? So what am I trying to prove? I need to stop for gas. That's what I'm trying to prove. I need to stop for gas. So what are some things that are given that would make you, as you're driving down the car, okay, I know that if my car runs out of gas, it will run out of gas if the gas tank is empty, and we will quit driving. That's just a fact. We could call it a postulate, we could call it a definition, we could call it all these things, but that's just something that we know to be about automobiles. It doesn't matter what we call it. So we're just going to call it a fact or a given. The other thing that we know is that when that little light comes on our dash that says gas, it means we're pretty close to empty. We can still drive, but we are in danger zone of running out of gas. So those two things I know just from having driven an automobile and maybe having run out of gas, right? So now we want to reason through this. So what I want to prove is that I do need to stop for gas. I'm given that if I run out, the car's not going to run, and when the light comes on, I'm getting close to that point. So those are two pieces of information. Now notice those givens may seem obvious in this case, and oftentimes they are obvious also. And the logic that we're going to go through, that we go through every single time our light comes on our dashboard. So if the gas, so we're going to start with step one. I said we always start with a given. I'm going to start with that thing. If the gas tank is empty, the car will not run. I just said that was a given. We know that. Okay, I'm going to start with that. That's given. That's a fact. We know that will happen. The gas gauge is on. How do I know that? Observation. I've made that observation. So, and notice when we do a proof, we always have to give the reason for the proof. With the first reason, it was given. The second reason, it is by observation. Now, in geometry, we don't usually use observation, but in this case, we are. And then the third step is the gas light. What's the next logical thing? Okay, the gas light is on, and you're like, okay, if the gas light is on, that means the car is near empty. How do I know that? That was one of those facts that I just know, right? That is a given fact. And I stated it as a given. So what's the next thing? Where do I go from there? Okay, well, therefore my car will soon not run. The gas light is on, right? And I'm basing that on step 1, 2, and 3. The gas tank's near empty, the gas light is on, and when it comes on, the car is going to run out of gas. Now this may sound a little silly, but some proofs get this silly. So the next logical thing is, if I want to keep driving, I need to stop for gas. That's the logical conclusion that we are trying to do, and that's what we were trying to prove. Yes, I need to stop for gas. So this is how we are doing it, and there are going to be times where the proof feels very, will feel very to the student, hey, this makes sense. I'm logically walking through this. And there's going to be other times that the proof seems like silly obvious, and the statements they're making are silly obvious. So expect that from the student, that sometimes it clicks, sometimes it don't. Once they start getting the rhythm of what you're trying to do in a proof, and there's a reason for even the silliness, what feels like silly. Once they start getting the rhythm, then the rest of the proofs will come together very good. Now, if you're using Harold Jacobs' geometry book, again, as I've said many times, he walks you through proofs all the time in the book. Sometimes you don't even notice it, and so that helps the student get really, really used to doing this. And for parents, here's the key. You don't need all the answers. You don't need any of the answers. This is an Aristotle moment, or a Socrates moment, I'm sorry. It's the Socratic method. Ask questions. But asking these reasonable questions of what am I trying to prove, what do you know, and what's the next logical thing you can conclude from that. And just let them do it. Let them put the Lego bricks together one at a time. All right, so again, they have some videos down below about proofs, more detail about proofs, probably more student-oriented about proofs, and we have a proof worksheet, cheat sheet, whatever you want to call it, down below also. And if we can help, as always, shoot us an email at support@AskDrCallahan.com.